In this demo, we want to show how we can use the new features in Java 8, like default implementations for methods in interfaces, in order to implement a mechanism to support extension methods. So basically, what we will have to do is to provide a way to extend a contract with methods defined either as interface or class, and based on that contract, provide a way that the user will be able at runtime to add new methods to the contract. So we'll start by creating a new Java project. Let's call it demo. We'll have to use Java 8 for that, and in here I will just create simple structure like having a package called demo. So basically I will have to provide something like an extension and allow at runtime to cast an object to the extension mechanism. So I will start by creating a new interface in this case, which will be called extension, and I will have a generic parameter for the base type that I'm going to extend. Okay, that's a simple interface like that. And what I would like to have in here would be to first have a reference to the default implementation, the default model. So I will have a method called base, and this will have a default implementation that will return null. So basically what I would like to have here is to be able, if I'm extending a generic T model, to have access to that model. So my extension in this way it will be able to use the relation has in order to access the base model. And I would like to be able to create an extension by calling a static method. So I'll have to have here a method that will create an extension based on a model and an extension contract. So let's call the type for the extension contract to be E, and this will be an extension. This will extend an extension of T, and it will also have a generic type T for the model, because this is a static method, so it doesn't have access to this generic type. This will create an object of the type of the extension. Let's call the method create, and it will have to have as parameter the type of the contract to extend to, and also the instance that's the real model. And in here I will have to, actually in Java 8 I'm able to provide the default implementation for this static method without having to say default. So what I'm going to do, first, I'm not able to, because I will use invocation handlers as proxies to implement this. I'm not able to provide this feature if the type of the extension is not an interface, it's not a simple contract. So I will have to check with reflection if this is an interface. If so, otherwise I will return null. If it is an interface, then I will have to create an extension handler which will help me to handle the invocation of methods from the E contract. Let's call it handler, and I will create this extension handler. I will create a class, but I will instantiate the extension handler in here of type T based on my instance, based on the model. So this will be the actual proxy. The class is not created, so I will create this class. But I would like to create this class inside my class, so inside my extension. Okay, it says that it doesn't have the constructor with one argument, I will just add this constructor. Let's follow the purpose of create method. I will have to get all the interfaces that's actually that have to be implemented by my invocation handler. So let's create a list of classes, and those will be the interfaces, and I will just use an array list for that. And what I'm gonna do here is to visit the type hierarchy of the model provided by the instance and collect all the interfaces implemented by the types in the hierarchy. So I will first get the class. Let's get the base type, and for that I will just get type get superclass. Okay. This will be actually will collect all the classes of the contract defined by the type. So as far as this type is not null, so while base type different than null, and it is an interface, remember that I'm not able to, so if it's an interface, I'm not able to implement an invocation handler based on classes. If so, I will just add in the list my type, my base type, sorry. Okay, and then I will just go one level up in the type hierarchy by getting the super type of this. Okay, I would like to set the content assistant for Java don't have delays. Okay, so in here, after I am collecting all the interfaces, all the contracts that have to be implemented by my invocation handler in order to fulfill the contract specified by the type. After that, I will ask the reflection mechanism to create a proxy for that. So I will get the reference of that, just call it proxy, and with the proxy from Java line reflect, I will say create new proxy. As a class loader, I will use the class loader of the enclosing class. Like for instance, I have the extension which has a class loader. The interfaces has to be an array, so I will just say interfaces to array, and I will set the length of the array to be the same as the size of the interfaces, and I will have to provide the handler that should be my handler already created. Okay, basically the new proxy in here, it is okay, this one is not able to use my handler because handler does not implement the invocation handler. So let's see if this can be done here. Yeah, that extension handler implements invocation handler, and now I will have to implement the invoke method. Okay, let's continue. With returning, the idea is that this proxy, by using the handler, will implement all the methods collected from all the contracts that are available to my type. So after doing so, I will return a cast of my proxy to the type of the contract. So now I have the method implemented. I will have to do the invocation itself. Okay. So in here, with my extension handler, what I would like to have is first to get instance, first to store in a field in my class the model. When I will be invoked by the invoke method, which will have as parameter the proxy, the name of the method, and of course the arguments, what I have to do here is remember that with create method I am creating an implementation for all the contracts in my type based on this instance. So I will be invoked because I am returning an object that has to fulfill this contract. I will be invoked with all the methods available to that contract, because I explicitly say that the contract should extend the extension. As you can see here, the extension contract has a method base that should return the instance, the actual model. So in here, I will have to see if the method is actually asking to get the base, to get the model. Let's check this first. If the base is equal with the name of the method. Okay, if so, I will also have to check that the method has 0 parameters, but this is just for making sure that everything is according to what I expect to do. So I get a parameter count, and this should be equals to 0. If it's that, then I will return the instance, because I'm expecting to get, when I call base, to get the actual instance that was sent to the extension handler. So as you can see, by default I am returning null, but this invocation handler is actually overriding the implementation of all methods because it is a proxy, and in here I will be invoked also with the base method. So this call will not go to the default implementation, but rather will go directly to my invoke method. So if the base method was invoked, I will return the model. Otherwise, what I have to do, first I will have to see if it is a method which has a default implementation. So I will get the class where the method is declared with get declaring class. I would like to do a lookup to get the method handler, method handle. With method handles lookup, I get a lookup by using the method handles lookup. And I would like to look up inside my class. Basically, what I like to do here is to avoid, the idea is like this. In order to implement my extension contracts that will be provided here, I would like to be able to do the following mechanism. Let me try to explain it briefly. Imagine that I have a model and I want to extend my model with additional methods. Those methods cannot be declared and implemented in a class. If it was it will be like this, I won't be able to use the class to extend the model, because I can only use interfaces for that. I cannot mimics the implementation of a class with a proxy, with an invocation handler. Therefore, this should be an interface. But what I would like to have is the ability to have default implementation of those methods. So in order for the method to be available, to be attached to the model, the method should be implemented by the interface. So in all the cases, my extension contract will hold methods with default implementation. In this case, because what I'm returning with the create method will be a proxy, all the invocations will go to invoke in that proxy. So although I have default implementations in my contract, in my extension contract for that method, I will override the implementation by having this proxy as the result of the create method. So all the calls will go to invoke. What I like to have here is to have a static dispatch of the methods, not to the invoke handler, but rather to the default implementation of the method in the original contract. Because of that, I will have to look up and see if the method is default implemented and forward the call to the default implementation. But the problem is that this is not allowed by the framework. In order to do so, I will have to change a finally field which allows to pass the call directly to the default implementation. So for that, I will get a field. I will call it allowed modes field. With my lookup, inside my lookup, there is declared a field called allowed modes. This field is declared final and has to be made available to be changed. So I will have a function called make field modifiable, and I will say make my field allowed modes field modifiable, and I will just create this method that for the moment does nothing. Okay, now that it is modifiable and also available to be set, I will say set this field to be -1, because this default method will allow me to reflect the default implementation. Unless I do that, I will get an exception because I'm forbidden to do so. And now, what I have to do here is just to ask the lookup, which is actually getting the default implementation of the method, to unreflect special, and I would like to unreflect special this method inside my type. Unreflect special, not setter, sorry, unreflect special. And after I'm actually discovering the default implementation of the method, I'd like to bind this to my proxy, which means that all the time the invocation will go to the proxy will delegate the call directly to the default implementation of the method. And now that I have the default implementation, I just want to invoke my method having the default implementation with these arguments. And this is all that I have to do, except that I need to make my field modifiable. So basically what I want to achieve with this implementation is each time a method is invoked, if the method it is the one that's supposed to return the model, then I'm just returning the reference that I stored previously. Otherwise, I will need to go to the default implementation of the method in the contract interface, make it available with unreflect special, bind to my proxy, and then just to get the context of the invocation, and then invoke with the argument that were passed. And now to make my field modifiable, this will be as easy as pie. What I have to do here, first, I don't care if the field is okay, this parameter should be named field. I don't care if the field is accessible or not. I will have to make it accessible. So set this field accessible to true. That's the first step. The second step, in order to change the final modifier on the field declaration, I will have to get directly to the modifiers field. Modifiers field. And for that, I will go to the field class and get the declared fields, the declared field with the name modifiers. Okay, this one can throw exceptions, so I'll just say I'll throw declaration, and I will just use one exception. Let's call it generic exception. That's one step. Okay, the next one. So what I have to do to change the final modifier will be to get the value of the modifier from the declaration of the field, remove the flag, the bit flag for the final, and then set it back to the declaration of the field. So the field is accessible, my field is accessible, I can set its value, but the modifier field is not. So I will first set the modifiers field to be accessible in order to be able to change it. And I will have to get the value of the field and set it back. But I can do that in one step by setting the value of this field for my field, for the declaration and of my field, and the value should be the previous value of the field get modifiers. This is actually invoking the modifier fields to get its value, and I will do a logical a bitwise AND with, in class modifier there is a mask to set the field final. If I will invert the value of that field and do an AND at bit level with the value for the modifiers of the field, I will then remove the value of the flag, and I will not affect the other bits. So now I'm able to actually have the field accessible, remove the final from the declaration of the field, so that in here I can set its value as to what I want. Now that I have my extension interface defined here, I would like to have a service that will allow me, if I define a model that's implementing an interface, and the interface is marked as extendable, then I will have a service, like a method out of the box, to allow me extend the model on the fly. So with this extension, with the implementation that we have, we don't need the fancy interface that I'm going to create now. But in order to allow the developers to design a class as being modifiable, as being extendable from the beginning, I can do the follows. So I'll just create an interface, call it extendable of t, extendable of t, extendable. And in here, I would like to have a cast method with the default implementation that will return a contract which is an extension to my model. So it's an extension of type t, and the method will be called as, its purpose will be to cast at runtime my model to a desired contract. So I will just say cast my model to this contract. And what the default implementation does actually, will use the extension and call the create method of the extension to actually have created a proxy and invocation handler for the contract of the extension based on the instance. But what's actually the value of the instance? That should be the reference to this, because I will be in a class. I can use this as the model. This will be actually the model. So I just have to suppress warnings because I know what I'm doing here. I would like to test it with a simple model. This will be the simplest model ever. What I'd like to have here is, I will just create a test class called model. My model will have only a text. You know what, I will just call this text, and my text will have a value, which will be a string. I would like to have for this a constructor, and the constructor will be using this value. So let me just create a constructor with this. Okay, it should be inside the class. I would like to create a constructor. Okay, I will do it by hand, no matter what. So I will have a text with a value, and I will just store the value inside my object. But also I would like to override it to string, to return the value. So this is the simplest model ever. And for this model, I would like to design it as being extendable from the beginning. So I will say that I like to implement extendable of type text. Okay, so in case my model is not implementing like that, I can use at any time the static method create of the extension interface to adapt it to whatever I like. But since I'm able to design my model, I can say let's make it extendable from the beginning, and now I can cast it simply just calling the as method from the extendable interface to cast it to whatever contract I'd like. So let's create an extension. Let's call it text extension. This should actually implement should be an interface, sorry. So I would like to have a contract called text extension that will implement my extension interface, and in here of type text, sorry, this is my model, and in here I can define whatever new methods I'd like to add to my already defined model. So for instance, in my extension I will just create a reverse method that will have a default implementation. So my reverse method will return the reverse string from the value of the text. So what we'll do, we'll get the value. Since I am extending an extension of type text, I will call the base method from the extension, which will actually return the text as being the model, and I can convert it to string to get the value. In my case, I will just use a simple string builder. As you can imagine, let's call it builder. I will create my string builder, and what I'm going to do here will be to iterate to my object but from the length -1 from the last element to the first one, and just append with the builder the corresponding char in my string, so char at index I. In the end, I will return builder to string because this is just what I like to have. Okay, so now how the actual consumer will look like. So let's create a program here that will hold the main, and what we would like to have here in my program would be to create a model, create text, just have my text. Let's create a new text. This string will be reversed. This is my model. Now with my model, I can either use the extension and call the static method create to adapt my model, to extend my model to a contract. But since my model is already designed to be extendable, I would like to say text, cast my text as text extension.class, and this will be actually a text extension. And because text extension extends the extension interface, it will have, of course, a base method. The base method will return the model that's holding inside by the extension. Of course, as you saw, this will actually invoke the proxy, the extension handler, which will look and check if the method invoked its base, and then it will return the instance, which is set in the constructor of the handler. That's one step. So with base, I can at any time access the enclosed model. But then I can call additional methods that are defined by the text extension. And in case the text extension, which is an interface, that means a contract, it's extending different other contracts, then I will be able to collect all those methods. However, in order for this to work, this will have to rely on default implementations on methods in interfaces that's been added by Java 8, because up to now I'm not able to implement with an invocation handler a list of classes on interfaces. So that's why I'm forced to use default implementation on methods that's available from Java 8. Of course, I'm not doing something fancy, just reversing the string. So I will get the value in here, and in the end, I will output the value as being reversed. Now when I run this, okay, I have a problem because I'm not able to cast my proxy to a text extension in here when I am creating. I will just do a simple debug on that. And the problem is that I forgot when I'm creating the handler. Let's see the problem in the extension, in the implementation of the extension. The problem is that when I am creating the proxy, I'm collecting all the interfaces that are in the hierarchy above my type, except my type. So in here, I forgot actually to add as a value in the list the type. So because of that, when I want to cast my instance to this type, my invocation handler to this type, I'm not available to do so because I am not explicitly added this to the list of interfaces that have to be implemented by my proxy. Okay, sorry for that, I forgot to do it. And now, when I run this, I'm not able to read it, but as you can imagine, it's reversing the text. Okay? It's not in Welsh, it's just reversing the text. So, what's the conclusion of that? Although Java does not allow extension methods as prototyping, we can imagine a way, using what's already in place with Java 8, we can imagine a way that this can be achieved. Okay, it's not supported out of the box by the language, but it looks like a way to extend actually a class with some contracts. So what we can do in here is to design the contracts to have default implementation on their methods that will use the actual model, so that at any time, based on this implementation in the contract, we can provide a way to cast the model to that contract, to the extension methods, and by that cast to use the reference to call all the methods of the extension. So basically, this is a simple way to achieve extension methods and prototyping in Java. Just define your extensions that will use your model, add your new methods to attach new features to your model, and then have a simple framework which allows you to cast your model to the extension, and by that to use all the methods of the extension. So that means that at any time we can have different casts, but those will actually be additional proxies with the implementation that you see here. So those will be new instances as wrappers on top of the model. By that, we will have invocation handlers that will handle all the methods addressed to the extension contract. However, those will not handle methods that will go to the base model. So if I will go here and call base, and with base I will call the model, the contract of the base, then I won't be able to intercept those methods. So they will go directly to my model. However, I can do that if I call the methods from the extension contract. That's about all. Thanks.